Untitled will be a proposed mission, or sort of a class of missions where the goal is to go to Mars and stay, rather than going to Mars and coming back after 500 days. Now, I'm not going to come back, but if the mission is successful, you will stay. And I wanted to say that this is not endorsed by the Mars Society. I did all this work before becoming executive director of the Mars Society. So, don't blame them. Hi, John. So, this is the NASA reference mission. One of the vehicles that was part of one of the NASA reference missions that has produced fuel on the surface of Mars and is now leaving the surface and going to rendezvous with another craft at home. Tremendous amount of equipment and fuel. Equipment needed to produce the fuel and the fuel to get off the surface. The vehicle itself. It's just pretty expensive to come home from Mars. And that started me thinking. By the way, that vehicle is not all the cost. You also have this vehicle that leaves Earth, flies by Mars, and you rendezvous as you pass and head home. So there's two vehicles needed to bring you home in one of the reference missions. You really can't get away from that too much. Here's another plan by Bob Zubrin. This vehicle is what brings you home. The bottom part produces fuel and gets you off the surface and heads home in this little thing, and it's a pretty unpleasant trip on the way home, by the way. Whereas this is the equipment you need to stay. And it turns out it takes about the same cost, the same launch vehicle to get that to Mars, to get that to Mars. So in this plan, half the cost of a Mars mission is coming home. The classic reasons to go to Mars are science, and then everybody says it leads to permanent settlement. Well, I disagree with that leads to. I think that, many of us, in our minds, we really are hoping that permanent settlement is possible, and that's going to be the ultimate economic and political and psychological driving force to go to Mars. It's really hard to justify a Mars mission just to get rocks and learn geology and learn about the history of another planet. That's all important. But if you had a permanent base there, that would be easy. So here's the outline of my talk. I already covered why go to Mars as much as I can in 20 minutes. There are valid reasons to go to the moon. It's a great place if you want to come home early or for tele operations. The nights are a little long. Anyway, does anybody have questions about what's on Mars? Every element you need for life is on Mars. You've got rock, silicon and iron and oxygen in the rock. The atmosphere is carbon dioxide. You can make oxygen from it. The carbon dioxide we use for growing plants. There's a little bit of water. There's nitrogen and argon. Does everybody know this? Any questions on that? Oh, and the fun part is 24 hours plus. You can stay up 20 minutes extra every night and still get 19 minutes of extra sleep. John?
It's just to remind people that besides water, on Mars you do have other volatile elements like sulfur, phosphorus, etc. that you do not have on the moon, even if you have those lunar co-deposits.
I don't mean to knock the moon.
Right. I'm not knocking it either. I'm just pointing it out.
We've already had explorers on Mars. There are historical analogies of you first send the explorers and then you send the settlers. Well, we've already sent the explorers, and we're going to be sending more explorers in the next decade. So I think that historical analog just doesn't hold. Now, there are problems. You can only leave to go to Mars at certain times. You can only come home at certain times, basically every 2 years. And let's see. So it's not like the moon where if something goes wrong, you jump back in the return craft, you push the button, and you're home in 3 days. If something goes wrong on Mars, you wait 100 days, 200 days, 500 days. You wait till the next launch window. Then you push the button, and it's still half an solar orbit, half a year to get home. And I'm not just making this up, but you can look at all the starting triangles are the times you can leave. I'm sorry, the dark triangles are the times you can leave Mars to come home, and the white triangles are when you make it home. And you can see, if you're planning to come home, if you miss one of these launch windows, you're not going to have another launch window from Mars for a certain number of months, and you can't take all of these possible trajectories with a given vehicle. Some of them require extra fuel that you may not have. Okay, I maintain that the biggest risk in a mission to Mars is the trip coming home. I think it's much more dangerous than the trip going out, and more dangerous than being on the surface. The reasons are, your ascent vehicle to get you off the Mars surface has been sitting there for a couple of years. You haven't had NASA technicians running all over it, pulling out the bad parts, doing the maintenance. Basically, no maintenance, no ground support. When you push the button, you don't have mission control. Right next to you, mission control is a 40-minute, radio delay away from you. You don't do a transatlantic abort on Mars because the other side of the Atlantic isn't on the planet. If you did do a transatlantic abort, your vehicle might not have a heat shield. Even if it did have a heat shield, there's no one to pick you up when you land. In some of the missions, you have to do an interplanetary rendezvous. This means if you miss it, you don't just orbit another 90 minutes and try again. Interplanetary rendezvous, if you're late, the other vehicle is going around the sun and won't be back for another year. Extra fuel and consumables. This is something that isn't mentioned a lot. On the Apollo 13 flight, the reason they survived was they had the accident on the outbound leg, and they had a spare spacecraft to live in, and they had extra consumables to live off of in that other spacecraft. If that had happened on the trip coming home, the LEM would have been back on the moon, or in lunar orbit, and they would not have had that spare spacecraft to live in. So when people design a mission, they try to design it so that the return trip is bare bones, so that you use up almost your last glass of water and your breath of oxygen just before about the time that you come back to Earth. You really don't want to carry extra consumables just for emergencies on the trip home. There's also extra radiation exposure, and on some mission plans, a lot more zero-G exposure. This risk was recognized in the reference mission plan. As an alternate strategy, the Martian surface is a safe haven. And they say that where you can have radiation protection, open space gravity, and I might add materials, air and water. And that this is a break from the previous viewpoint that viewed the Mars surface as hostile. The Mars surface is not as hostile as open space, interplanetary space. Okay, so much for the risk. Now getting into cost. 17 tons of consumables to eat and breathe on the way home, and you really can't use, the big, heavy, closed life support system for this because then that takes extra weight. Whereas you can justify, heavier equipment on the surface because it's used longer. I showed you the cost resuperance plan that where one vehicle, half the cost brings you home and the other half the cost is to stay there. This is the 97 mission plan, the Earth return vehicle and the Mars ascent vehicle. So again, half of the launch cost brings you home. And I just tried to itemize the expenses. I've already mentioned the consumables. In the event that you're not sure you can leave on time, if you're worried about that interplanetary rendezvous, you might want to have extra consumables on the surface. But 2 years of extra consumables, why not just stay 2 years? Okay. And I'm not saying that everybody should stay. There are reasons to come home. One of which is psychological. If people don't get along with each other, some of them come home, they can shake hands with congressmen, they can lobby for more funding, etc. But bringing a crew home just because the follow-on mission has not been funded, I don't think is a valid reason, because a very small amount of resupplies can keep them going on the surface. How am I doing on time? Oh, okay. Right. So here's one of the reference missions. The green, so there are 3 launches, and then the green is the period of time. This is the time scale in years. Green is the period of time that the crew is on the surface, and then you send more vehicles to supply as backup for the first crew or to supply the second crew. Then the second crew is on the surface, then the third crew. So my proposal is just extend the crew. Instead of the crew staying there 500 days, stay 6-8 years, then half of them come home and the rest stay the rest of their lives and build up a permanent base. Second crew, half of them plan to stay indefinitely. They have return vehicles, but they hope not to use it. And you can just see, how much crew time you have on the surface compared to how much crew time you have on the surface. So even if they spend 80% of their time doing housekeeping and growing plants, they still get more science time. So here's my mission scenario. Do additional testing on Earth, ideally a full-scale test habitat on Earth. You can send it to 6 people. I just wrote this up saying 4 people go in year 0, and their major goal is to set up the habitats and start growing food, experiment with food growth. Let the rovers go out and do as much of the science as they can. When the scientists back on Earth want intervention, like go look at that rock, then send them out. And they'd also be repairing the rovers. The second crew joins them, try to get good-sized plant growth and real food production out. We have about a 6-year supply of food, but you hope not to use it all. And maybe by the third crew, you start doing real construction. How much extra mass does it cost to stay that long? Well, to go from 2 years of consumables to 6 years is only an extra 4 tons out of 25 tons. I also threw in twice as many spacesuits, an extra rover, an extra pressurized rover, and extra spares, but it's still only 10 tons extra, which on this scale, emissions of this scale is not much. But you actually want to stay permanently, not just an extra 6 years. So I would like to also throw in water extraction, greenhouses, equipment to make paper and felt. You're going to want paper and clothes, sewing machines. But that doesn't add up to much. You take your air popcorn popper. How much does it weigh? Something to separate grain from chaff would be about the same mass. So I took kitchen appliances and I estimated some of these costs, not including the greenhouses. I came to 9 tons. And by the way, I really would like help refining these numbers. These are very rough estimates, and you can see the blanks where I just didn't even know what to put in. So if anybody has experience in this field, send me an email with, hey, why don't you, this is low, this is high, look at this source. It'd be nice to split the return crew vehicles in half so that they carry 2 people home. And now you can fit them on smaller launches. You don't need a shuttle C to launch the return vehicle. You can fit them on smaller vehicles. So I would say send 4 vehicles, 2 of which produce the fuel and 2 of which get you into orbit off the surface. And I estimated 7 tons. Unfortunately, there are people within 50 miles of here who could do a much better job. Spare parts. Downstairs below where I used to work was a machine that could make a part overnight. So if you're on Mars and your little trackball or your carriage return key on your laptop breaks, you pull out the spare, you plug it in. If that breaks, then you pull out the CD-ROM and you make a new one. And saying, it keeps breaking in the following way, redesign it and FTP the file via the internet to .mars.solarsystem, and I will produce a new spare part.
Does that only include plastic parts? Or can you do this with metal?
Sorry, John, I'll get to that. This particular scheme makes UV curable polyester. I shouldn't say polyester. UV curable resin. It scans a laser beam across a thin layer of resin, lowers it down and scans again, builds up a part layer by layer. You can make something, several inches across overnight. Okay, there are other plants that use dust, where they put a layer of dust across and they glue it down. You could probably do that with dust from the regolith. It doesn't have to be too strong. There are other plants that melt. There's one that's it's a glue gun. It's like my child's glue gun, only it's computer controlled and just glues up layers of parts. You can also use this scheme to make a mold to then make metal. So you have a couple of these rapid prototype machines. You also have a small lathe for turning metal, a little tiny 6-axis milling machine. One of my favorite slides. Would you trust a major, expensive national program to these folks?
Yes.
The Mercury 7 astronauts on desert survival training. Okay, so when that Mars descent vehicle is landing on Mars, somehow you're going to get the picture of the parachutes, and those parachutes are going to have disembodied body parts drawn on them, because those will be the patterns for the clothes. So when they have spare time someday, they're going to go out and find the parachutes, cuddle along the dotted line, and sew the spare clothes. Notice I say spare time. Okay, and I drew up a page for every 2 years. I think I shouldn't go through these details. I have about 4 of these. Yeah. Well, in the interest of time, the reason to do this is if you have round-trip missions, it's too easy to stop for political reasons. If somebody gets killed, you say, oh, it's too risky, etc. Whereas if you have a series of one-way missions, it's easier to continue. Even if you cut off most of the funding, you could still send, a Delta-class rocket with a few spare parts. And the ultimate irony would be is if somebody got killed on the way home and that canceled the program, people would use that as proof that it's too dangerous to settle Mars. Thank you very much, and please send me advice via email. John?
Yeah. I'm especially interested in the issue of crew size. Just in the last few weeks, there's been more stuff about psychology of small crews. Feel like 3 people, 2 people against one, in about 2 or 3 months,
Yeah.
you start making factions, no matter how skilled and how good the guys are. And my basic position is I agree with the basic overall plan, but a crew size of 3 or 4 is much too small. You need at least 6 to 8 minimum crew size.
Okay. I don't want to get involved
Right.
in what that size would be, because my plan is scalable for any crew size.
I
Instead of
understand.
sending 4, you send 4 to stay.
Right.
Instead of sending 6, you send 6 to stay.
Yeah.
Now, when I did whitewater canoeing, it was 3 vehicles, 3 boats was the minimum, and it was usually 2 each, and that was 6. And for longer trips, I would prefer more. Let me point out that if the first crew stays and overlaps by 10 years with the second crew, then it doubles the crew size. So you can send 6 and then 4, and then you have 10 on service. And that makes for a really safe community. John?
I just want to put in a plug. Red Planet Incorporated was recently formed to address, among other things, exactly this scenario. We'd be more than happy to host your neighbors the core of our website on the subject. And if anybody is interested in working developing this model, please contact either Bruce or myself.
Gee, John, I'd like to meet you and talk about that.
Amazing. And you guys never done.
Is there a question from someone I don't know?
This is based upon the 3 vehicle scenario.
I started out basing it on Mars Direct by Super. But then when the NASA reference mission plan came out, I switched. So I apologize for switching back and forth. But No, for almost every mission I've seen, you save about half the cost if you don't have to come home. Now, I'm not saying you would actually save that money. You would put that money into additional equipment. So I think my gut feel, and I'm trying to work the numbers, but my gut feel is that a permanent base would cost the same as the same number of round-trip missions. You know, let's say 3 round-trip missions. I think you could have a permanent base for the cost of a permanent base for 3 crews for the same price as about 3 round-trip missions.
Were you describing 2 original supply in a crew and then alternating supply crew after that? Or were you still doing 2 supplies in a crew between each crew?
I would add an extra supply before the first crew. So, okay,
2 supplies, 1.
Okay, let's take the 97 reference mission. That's 1 ascent vehicle, 1 return vehicle, 1 supply vehicle, and 1 crew vehicle. And I would add an extra supply vehicle. Okay. And then for the second crew, it's 1 ascent, 1 return, and 1 combination crew and supply. And I might add a smaller extra supply, but may not be the full Shuttle C launch. And then after that mission, then the return vehicles you start leaving back on Earth. The vehicle for the return vehicle for the second crew might stay in Earth orbit and be used as a space station. The return vehicle for the third crew might stay in the Smithsonian. You can launch it on 2 years' notice. And you really save money when you do that. I think we're
Yeah, I'm going to suggest that